Okay, so we are doing chapter 17.2 on page 479. 479 says use a ray diagram, draw a scale solving problem 2. So the first one that we're going to be doing is we're going to be doing concave. So based on that, you should have an arrow going up. You should have your lens going that direction. You're going to have a ray that goes here and there. That's your ray 1. And you're going to have a ray going here and here. And this is your ray 2. And that's all you need for question number 1. So we're talking about concave. And then we're going to do convex over here on the next problem. Okay, question number 2, which is this one's 13, this one's 14. Number 14 says you place a 36 centimeters in front of a concave mirror with a 16 centimeter focus length. Determine the image position. The formula that you're going to be using is 1F, because we're trying to find the force between them, 1XO plus 1XI. So XI equals XOF over XO negative F. So it says it's 36 between each other. We're going to put that on top and on bottom. And it says that it's 16 inches from the focal length. 16 inches are on the top, and you're going to have a negative 16 inches on the bottom. So this is what your formula is. So if you take your calculator and you do alpha y inner, 36, 16, 36 minus 16, you get 2.88 is your answer for question number 14. And what I would do is I would move that over to 28.8 because we want them in centimeters. So that's 14. Number 15. Number 15 says you have placed a 3 centimeter tall object 20 centimeters from a 16 centimeter radius concave mirror. Determine the image position and the image height. So we have to do 2 things here. First thing we're going to do is the image position. So we're doing the same thing as we did here, except we're going to be doing exactly the same thing. So this time, you have 20 centimeters, and you're going to multiply that by 16 centimeters over 2, dividing it by the same thing, 20 centimeters, and we're going to subtract 16 over 2. So we're doing the same thing as we did on the very first one. The only thing that we're doing different is we're using different numbers based on what we're doing. The reason why we're doing it over 2 is because it's half the distance. So alpha y equal, we have 20. Alpha y equal 16 over 2. Close your bracket, go down, 20, subtract. Alpha y equal, and that's going to be open bracket, whoops, it's going to be 16 over 2. you should get 1.33. So your answer is 1.33 centimeters, which if you move it over, it would be 113.3 for that first thing that's asking for, which is asking you for your image position. The other one is your image height. So for your image height, you're going to do HI equals negative X and HO, yes ma'am, over XO. All right, so based on that, we're going to take the same numbers we had before. We're going to use our total here, which is 13.3 centimeters. They're going to multiply that by 3 centimeters. And we're going to divide that by 20 centimeters. Yes, ma'am? Well, I only have a small pen. 13.3 centimeters times 3.0 centimeters over 20 centimeters. Alpha Y enter. Open bracket, 13.3, 3.0, and 20. That gives me 1.995. So that is the height of it. This has to do with concave, okay? And we're going to go to convex in a minute. I'm going to give you a minute to write that down. So that means we're going to go to the next page, which is 480. We're going next. Convex. So now for convex, the first thing it asks you to do is it asks you to find the object of 2 centimeters in front of a convex mirror, negative 15 centimeter focal length, find the image position using both scale diagram and mirror equation. Just like we did here for concave, we're going to draw another image for convex. 17. So on this one, instead of the mirror going this direction, the mirror is going to go the opposite direction, which is going that way. We're going to have our rays, one going up and down. And our other ray is going in that direction. This is number 17, ma'am.
We don't do 16?
I did not. I skipped it.
Okay.
Here's my focal for this one, which is negative 8.6 centimeters. So the only thing for 17 asked us is to draw. Now look, when you're doing your foldable, concave has your mirror going in that direction. Convex has your mirror folding in this direction. As you can tell, the rays are going to look different.
You said that's negative 8 point what?
8.6 centimeters. So if you look, your ray is going here and out. This ray is going in and out again. So as you can tell, they're kind of crisscrossing. These here are kind of going as an angle. Those are something that you should draw on your foldable. Number 18. Number 18 said, 19. Sorry, that's 18.
You still 16 in.
I did, because why I do more with 16 was similar to 15, so I didn't do that. 17 is the challenging problem. 18, I just drew. 19, I'm getting ready to do. And I'm only going to do 19, and that is it. Because I chose 2 problems from this one. Because I want to kind of give you a little example of concave and convex. So when you do your foldable, you'll know how to do it. Okay? So, it says a convex mirror is focus length of negative 13 centimeters. A piece at 6 centimeters diameter light bulb at 60 centimeters from the mirror. What is the light bulb image position and diameter? So we need to know the position and diameter. It's just like what we did here. So you can see it parallel to each other. So XI equals XOF over XO negative F. Just like we did here for position. This here is concave. This one here is going to be convex. So you can see the difference between the position and the height and the position and the height of a convex lens. So on this one is 60 centimeters times negative 13 centimeters divided by 60 centimeters. Subtract negative 13 centimeters. You do the math, you get negative 10.7 centimeters. So if you look, different positions, but pretty much the same formula that we use for both. The only thing that's different is this is a subtracting a negative. This is just subtracting a positive over 2. So I want you to see those differences. The next thing we're going to do is we're going to do our height for number 19. So for our height, same formula as we used before. Negative X, HO, what baby?
You slide back for a minute. So
And then HO on the bottom. So what we're going to do,
that go with 19.
this is the
No, what you
position.
writing now?
Yes, ma'am. They both go together.
Okay.
This and this go together. This and this goes together. Okay, baby?
Yeah, I was trying to figure out what you was writing.
It's okay. You asked. Negative 10.7 centimeters over 60 centimeters. When you do the math, you get a plus or negative 1.78. So here, we'll move up, baby. You up here. Come on up
You
here.
stay in front of me.
Oh, I'm sorry. Give me a second. And that's the ending of that answer. Please make sure you submit that online. Appreciate it. Thank you very much.